Alright guys, in this video we are looking at quadratic functions in vertex form. As students, your objectives are going to be to graph quadratic functions in the form f of x equals a, and in parentheses, x opposite of h squared plus k. That is called vertex form. We're going to look closer at that. That's really what this whole section is all about. And you're also going to want to be able to determine your vertex, domain and range, and the axis of symmetry for a quadratic function in vertex form. So let's begin by defining what vertex form is. Vertex form is when you see a quadratic function, meaning the largest exponent is 2. When you see a quadratic function and it's written in this form and a cannot be equal to 0. And, well, why? Let's answer that question. Why can't a equal 0? If you substitute in 0 for a, then the product would be 0 for that first expression there, that first term, and all you'd be left with is 0 plus k, which is k. And that squared term now has been eliminated. You only have a constant. You only have that k value, and you're no longer working with a quadratic function. So it's really important a has to be a number other than 0. This here is a graph of the parent quadratic function, and I'm going to highlight some stuff on the screen here. This is a table of values, and it was found by just taking this x value, -3, and plugging it into your function. -3 squared gives you 9, and you can not really quite, you can barely see that point right here. That would, I'm sorry, over here, -3, 9. Okay, so all of the table of values have been plotted here, and some important points that I want you to recognize are right here. This is your vertex. It's at 0, 0 for the parent quadratic function. And this line that is cutting through the middle, that is called your axis of symmetry. And we're going to write that down in just a moment. But the equation of that line is a vertical line, so it has to be x equals, think about hoivux. X is for a vertical line and is going through your vertex where the x value is in fact 0. So some vocabulary here. The graph of a quadratic function is a curve called a parabola. And it is the axis of symmetry that divides a parabola into 2 mirror images. So on either side of that axis of symmetry, you're going to have 2 mirror images. And I'm going to expect you to draw that axis of symmetry for every parabola that you graph. It's just as integral as the parabola itself in my eyes, and it's really going to help you tremendously. And that low point or high point is called your vertex. It's where your graph kind of turns. So, some properties when you're looking at a quadratic in vertex form. The vertex is always going to be HK, where that H is the opposite of what you would see in the equation. And the axis of symmetry is x equals h. It's actually that x value from your vertex, that h value. And it is an equation, so you have to write it x equals. Otherwise, you're just giving me a number. I want an equation of a line. If your a is greater than 0, it's positive. It's a happy parabola, and it's opening up like a smile. And conversely, if a is less than 0, it is negative, it's sad, and like a frown, it will open down. All right, and let's say that we have the absolute value of a greater than 1. So examples of those numbers, if you want to write them down, examples of a values could be like 3 or -3, 5, 7, -10. Those are all examples. It's going to make your parabola narrower than f of x equaling x squared, which is your parent function. Conversely, your parabola will be wider if the absolute value of a excuse me, is less than 1. Examples of those types of numbers would be like 1/2 or 1/4 or -0.9. Those would be examples of that type of a value. All right, so let's work through an example of graphing an equation that is in vertex form. Sorry guys, I don't know why my voice is suddenly just like going out. I'm going to try and see if a cough drop will help. Well, these are really good. All right, so we are graphing this quadratic, and so the first point you want to look for is your vertex. And so I'm looking here at my equation. This is the h value, and this is k. But what do we have to do with h? We have to make it opposite, which means the x value would be 2, opposite of the negative, and the k value would be -4. So we'll plot that point to -4, and that is the place where my vertical line will go through. And I sketch that right now because I'm going to reflect while I go. Okay, so let's pick some points that are just on either side of our axis of symmetry because we'll just reflect them. And I'm going to pick smaller values, so I'm going to go with 1. And I'll plug that into the equation. 1 minus 2, that's -1. -1 squared is +1 minus that 4 gives me, ooh, that should actually be a -3. I am so sorry. Will you change that? It should be a -3. And it is plotted correctly, as you see down there. And then I'm going to reflect that onto the other side of my axis of symmetry. See, they are equal distance away, and they are perfect little reflections of each other. All right, my next point I'm going to pick is again on the left side of my axis of symmetry. I'm going to let it be 0. There's no right or wrong values of x to pick here. I'm just trying to pick easy numbers because, well, it's easier to multiply. 0 minus 2, that's going to be -2. -2 squared is 4. 4 minus 4 is 0. So I'll go ahead and I'll plot that point and reflect that point. And I'm going to be looking for at least 5 points when you guys are making your quadratics, when you're graphing them. So we have 5 points here, so we are good to go. Now you would just connect those and create a nice parabolic shape. Now I cannot do that on my computer. I've spent 5 years trying to figure out the best way to do this. I'm not there yet, so I'm going to just trust that you can make a nice curve. And let's try some more. Okay, we now have a new quadratic in vertex form, and our vertex would be the opposite of h, which is going to be -1, and then our k value, which is 4. So we plot that point, -1, 4, sketch our axis of symmetry through it, and then I'm going to pick points on either side and reflect them to create my parabola. I'm going to choose on the right-hand side because those points are include 0, and they're going to just be a little bit smaller. So I'm going to go with 0 next, and when I plug that in, I'll just have 1 squared, which is 1, but then I'm supposed to take the opposite of that. You see here, I have, this would be like 0. Look, it looks like a big 0. So 1 squared is 1, but then I'm supposed to make it opposite. So that would be -1 plus 4, so that'll give us 3. So we plot that point and reflect it. And then let's keep going there on the right-hand side. Let's do 1. All right, so when I plug in 1, it would be 1 plus 1, which gives us 2. 2 squared is 4. Make that opposite, that's negative 4. So plus 4, then we're at 0. So 1 is going to be at 0. And I will plot a point symmetrically, just 2 units away from my axis of symmetry, also on my x-axis. And I have 5 nice points there. You could go ahead and try at 2 and see how that works. But really, with this, you will be able to make a nice parabolic shape. And now I want you guys to try this one on your own. Go ahead and pause the video and try to sketch this, finding your vertex, your axis of symmetry. Make sure you have at least 5 points and make your nice parabolic shape. So pause the video now and do that. All right, here it is. Your vertex would be at 4, 3. You could have the points 3, 1, and 2. I'm sorry, that should be 2, negative 4. And it should look really pretty like this. All right. Now, I have a cool little trick for you, a graphing shortcut. Because sometimes you get to working with things and you don't want to necessarily have to grab your calculator and do all this mental math. So here's just a little, I really like it. I think it's super cool. If you don't like it, you don't have to use it. But for using this graphing shortcut, like we've been doing, the first thing we do is we find our vertex and we're going to plot that. And it would be at negative 6, positive 2. So that would be our vertex. And we would also be able to sketch our axis of symmetry. And now 1, 3, 5, that kind of tells you the rates of like slope between each point. So let's say that we go over 1. Well, what you would do is you would take your A value, which in this case is negative 1, and you would multiply it by 1. And that gives you negative 1. So when you go over 1, you'd go down, in this case, negative 1. And similarly on the other side. Now if you go over 2, you would go up, or in this case it's going to be opening down, 3 times your A value. And so 3 times negative 1, that means I'm going to go down 3. So let me make sure you guys are tracking here. We're going to go from, hello, come on little flashlight. Sorry, we're going to go from here, we're going to go over 1 and then down 1, 2, 3. And there it is. And we'll not be able to go on the other side because the coordinate plane doesn't really work there. And now if we go one more point over, it would be times 5. So from right here, we're going to go down over 1 and down 5. So that would be 1, 2, 3, 4, 5. And there is that little guy. All right, and then you would just create a nice sketch there. And let's go and try another one. Sorry for that little shining thing in the middle there. I can't seem to get it to leave. Okay, so here we are. Now we're going to find our vertex again. Our vertex would be right here. It would be opposite of 2, so that's positive 2, down 3. That gives us then our axis of symmetry as well. We're going to go over 1 and take 1 and multiply it by our A value. So then we're going to go over 1 and up just a half. So right about there. And we'll reflect that point on the other side. And now say we go over 2. Well, over 2 means from this point you're going to go up Well, 3 divided by 5, that's like 1.5. So over 1 more, I'm going to go up my half and a full 1 and reflect that point. And let's see, I think I know that's 5 points, but I think we can put another pair on there just to make it a little bit better curve. So if I go over 3, then that would be 5 times 1/2, which is going to be over 2.5. So now I'm 3 units away, and from right here, I'm going to go up 1, 2, and then just a half. And I'll reflect that point on the other side, equidistant from my axis of symmetry. And you would just connect that and make a nice parabolic curve. This last one, I want you to try and do it by yourself, and I'm so sorry. I was trying to use my phone with this cool new app, and now it froze, so I'm really sorry. This should not be there. You can just ignore it. Pretend it's Rudolph. Okay, I want you guys to try this one by yourself. All right, this is what it should look like. And it's pretty cool because, you don't have an h value, so your h would just be 0 and your k is -5. That's why our vertex is down here. And your a value is 3, so you go over 1, and 1 times 3 gives you up 3. And then if you go over 2, it'd be 3 times 3, so that's up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And reflect that guy, and I cannot go up any further, so I know I included this, but our graph does not extend 15 more digits. So that is it. I hope you liked the shortcut. If you had any questions or comments, write them down. We'll talk about them together. I will see y'all later.